Hi everyone, this is Karthika, Faculty of Physics, working in SNS College of Technology. In this session, I am going to explain about the few topics about the fiber optics. So here we can see the structure of fiber optics. So it consists of core and then cladding, buffer and jacket is there. So core is made up of glass or plastic with high index of refraction than the cladding, and it carries the signal. And then we can see the cladding. It is also made up of a glass or plastic with lower index of refractive than the core. And then buffer, it protects the fiber from damage and moisture. And then the jacket, it holds one or more fibers in a cable. So next we can see the types of optical fiber. The optical fiber are the based on material, number of modes and then refractive index profile. So in material we can have two types, that is glass fiber or plastic fiber. Number of modes, it is classified into single mode fiber and then multi mode fiber, and then refractive index profile, step index fiber and then graded index fiber. So next one is based on material. Glass fiber is made up of mixture of metal oxides and silica glasses. Example, core is made up of germanium dioxide and silicon dioxide. Cladding is made up of silicon dioxide. Plastic fiber, it is made up of plastic which can be handled without any care. And example for this core is polystyrene, and cladding is methyl methacrylate. So in based on mode we can have a multi-mode and single mode. So in multi-mode we can see it carries more than one light source because the core diameter is very much higher than the single mode. So in single mode it carries only one light source. And then we can see the based on index. Here we have a step index fiber and then the graded index fiber. In step index fiber, the variation of refractive index of air, core and cladding varies step by step, and then the types of fiber is known as step index fiber. So in graded index fiber, in fiber optics, the refractive index is maximum and then it gradually decreases to the core cladding interface. So it is called as a graded index fiber. Next we can see about the comparison between single mode and multi mode. Here we can have only one light source. In multi mode we can have more than two light source, and launching of light and connecting of fiber is very difficult, but launching of light and connection is very easy, and installation is difficult as it is more costly. Fabrication is easy, and then installation cost is low. Losses in optical fiber. Attenuation, the other name for loss is called as attenuation. Here we have three attenuation, that is absorption, scattering and then radiative loss or bending loss. So in absorption, it is related to the fiber material. So the material may have a missing of atom or a group of atom, or sometimes that may have hydroxyl ions. So due to that, some amount of light can be absorbed by the material. And if we go with scattering, it is associated with both fiber material and structural imperfection in the optical waveguide, and then radiative losses. So here we have a microscopic and macroscopic. So in microscopic, that might be due to the manufacturing itself, we can have a microscopic bending. And in macroscopic, the radiative loss, that is the radius of curvature may be increased compared to the core diameter. And then another attenuation is called as a dispersion. So when the optical signal can be sent into the fiber, and in the output the pulse can be spread or broadened, so this is called as a dispersion. So here we have a different types of dispersion, that is called model dispersion, material dispersion, and then waveguide dispersion, and then polarization is there. And finally, the most important application of a fiber is nothing but fiber optic communication system. So in this we have major three components, that is nothing but a transmitter, optical fiber, and then the receiver. So the transmitter transmit the analog signal into the digital, and then that can be converted into light source that can be traveled to the optical fiber, and finally it can be received by the detector. Again it can be converted into digital, and then finally we receive the analog signal which we sent in the input. So this is the fiber optic communication system. Thank you.